Okay, so for this lesson, we are going to be dealing with a new type of function, an absolute value function. And we are going to graph and write the actual equations that represent these functions. So the vocabulary should have kind of given you a preview of what to expect. What I want to talk about in this first video is the parent function of absolute value functions. And that parent function is just y equals the absolute value of x. Another way I could represent this is f of x equals absolute value of x. So you'll see me do that every once in a while. So the graph of this absolute value function, if you could tell from the graph I showed below, that graph is going to be V-shaped. Okay, it's going to be V-shaped and it is symmetric, and that's going to be big with graphing. The symmetry of this graph allows us to do the graphing a little bit easier. So it's symmetric about the y-axis. So for every point, xy, there's a reflection of that point also on the graph. So this just shows that symmetry with 2, 0, and that should actually be 2, 2, 2, 2, and negative 2, 2. The highest or lowest point on this graph of an absolute value function, we call that the vertex. And that can be a maximum value, a highest point, or a minimum value, a lowest point. The vertex of the parent function is 0, 0. So when we talk about transformations, we're going to be doing a few different things. We're going to be reflecting, we're going to be translating, meaning shifting around, and we're going to be compressing or dilating, making the graph skinnier or wider. So for different values that we multiply by our parent function, you see we're multiplying our parent function by this value a. When we multiply our parent function by a value of a that is bigger than 1, the graph gets vertically stretched, okay? And the graph becomes narrower. So that v becomes skinnier. When that a value we multiply by our absolute value, our parent function, when that value is less than 1, meaning it's like a half or 2/3, the graph is vertically shrunk. Gets compressed. So that graph looks wider than our parent graph, okay? It looks wider. So moving ahead, I'm going to give you two different functions, and what we are going to do is we are going to transform them based off of the number we're multiplying. So our first function, I'm going to write it off to the side so that we can write our transformations a little bit easier. Our first function is y equals 1/3 x. Okay, so we have 1/3 times the absolute value of x. So what we are going to do is we are going to first talk about how it's being transformed, and we are going to graph the parent function and our transformation. So the graph of this function, the transformation is that there is a vertical shrink. By a factor of 1/3. Okay, so first I'm going to show the parent function, and I'm going to show what our transformation is going to look like. So first, parent function. Parent function has a vertex at 0, 0, and essentially you think of it as, to the right, you essentially have a line with a slope of 1, and to the left, you have just the reflection of that line. So that's what that parent function looks like. Our transformation, I am going to do in green, okay? And this graph is going to be wider. So how I drew that first line with a slope of 1, all I do here, I draw that first line, but with a slope of 1/3. So I start still with a vertex of 0, 0, but I go up 1 and right 1, 2, 3. Up 1 and left 1, 2, 3. And we can see this graph is wider, okay? The graph is wider than our parent function. So that's a vertical shrink, making our graph wider. The next function I'm going to give you is going to be a vertical stretch, and I'm going to show you something else. So our next function is going to be -2 absolute value of x. So this actually does two things. I'm just going to write just the transformation. It's a vertical stretch by a factor of 2, and it is a reflection over the x-axis. Because basically what I'm doing is I'm taking all my outputs and I'm making them negative, meaning this flips it over the x-axis. So again, I'm going to graph my parent graph. So we talk about that as that slope of 1. And I'm going to draw my line. And I'm going to draw just the reflection of that over the y-axis, okay? And then to draw the transformation. Talked about slope before. This is like a slope of 1, my parent function. For this transformation, I think of that slope as -2, down to right 1, down to right 1. And it is just using that symmetry to draw the other half of our graph. So we see a graph that is reflected and skinnier. So that's what multiplying by -2 does to our parent function. So this guided practice, I just give you one function to graph, and I want you to be able to write the transformation and draw the transformation. You can draw the parent function along with it, but it's not necessary. I'm just doing that to illustrate what multiplying by 3 does. So take a few seconds, pause the video, and then I'll start it back up with my solution. Okay, so the way I looked at this, I am multiplying my parent function by a number bigger than 1, so that's going to stretch it vertically, and the number is 3, so it's stretching vertically by a factor of 3. That's where I get a vertical stretch. Now, as for my graph, I graph my parent function, and then I just thought of this as basically drawing a line with the slope of 1, or slope of 3, and then using symmetry to draw the other half of that graph. So it's a skinnier graph. It's still facing up because I didn't multiply by a negative value. So in the next example, before we move on, I have you graph a function in a different form. So now, in this form, we are changing the vertex as well. So before I do anything else, I'm going to indicate what that vertex is. So for this graph, our vertex is going to be the point. If you look at that form up top, it's going to be the point HK, if you see that. X minus H, which means the opposite of H, and then K, whatever value K is, we keep the sign. So in this function, it's a little counterintuitive, and we will go through examples of this, but our vertex is the point -2. I get that from the +2, and it is -1. Okay? We will talk more in depth about why that is -2 when we have +2, but I want you to remember that's the vertex. So I'm going to graph the parent graph first, and then I'll describe some of the features of this new graph that we have. Okay? So from what we did before, we should know that there's 2 transformations that we can identify here. This is a reflection first. It's a reflection over the x-axis because that's a -3 there. And it is a vertical stretch by a factor of 3. And it's important that we write these transformations down, because then it gets us thinking about what these numbers do and where we get those numbers. So I get the reflection from that negative number being multiplied by the absolute value, and I get the stretch because I multiplied that absolute value by 3, by a factor of 3. The last thing is this translates or shifts our vertex. So this is a shift. We'll just say shift. From the point 0, 0, it's a shift left 2 and down 1. Because my new vertex, and I'll show that in green, my new vertex is the point -2, -1. So I basically took my vertex and shifted it. And from before, when we talked about slope of our line here, that first line we're going to draw is -3. So from my new vertex, I'm going to go down 1, 2, 3, right 1. And then that symmetry shows me the V shape. What that should look like. And it should make sense. We shifted our vertex, we reflected it, it's an upside down V, and it's skinnier, right? It's skinnier, it's a vertical stretch. So what I'm gonna have you guys do next is I'm gonna have you move on to the next part of this lesson, and you are going to do a little bit of practice with just the graphs and recognizing vertices and the different transformations. Okay, so you can move on to the next part of the lesson.